All right, so if we move on in multiplication to talk about exponents, what an exponent is it tells us that if we have a to a power of n, then we're multiplying a with itself n times. So as long as a is a whole number and n is a whole number that's not 0, then we know that a to the n power is a times itself n times. And by convention, we have to just kind of agree that a to the first power is just a. That also, we know if we go into a to the 0, we define that as 1 if we let n be 0. So when we have exponents, we have a couple of properties. So if we have two numbers, a to the m power times a to the n power, so we have the same base, a, but different exponents, what this should yield is a to the m plus n power. And now that makes sense, because if you think about a to the m as multiplying a times itself m times, and then we also multiply that by a multiplied by itself n times, then we'll have a, m times a, n times. In total, that would be m plus n times. If we take exponent a to the m power and then raise that to an n power, what will happen is we'll get a to the m times n power. And so again, this makes sense if you think about a to the m as a times itself m times. But then we think about to the n power, that's taking a to the m times a to the m times a to the m, n times. And so since we just saw that a to the m times a to the n is adding the exponents together, we would add the exponents of m to itself n times, and by the definition of multiplication as repeated addition, that tells us that this sum of all the m exponents will be m times n. If we have different bases for our powers, then we have the same exponent, then a to the n times b to the n is a times b to the n power. And this is just because we have the commutative property of multiplication, a times a times a times a times a n times, and b times b times b times b also n times. Because multiplication is commutative, I can just rearrange the order in which I multiply these things to write it as a, b, a, b, a, b, a, b, n times. And because of the associative property, I can group these things together and see that that's a times b to the n power. If we want to go back from the property that we talked about earlier, that a to the m times a to the n is a to the m plus n, we actually can go the other way with division and say if we're going to divide a to the m by a to the n, we subtract the exponents instead.